This lesson is on subatomic particles and the quantities on the periodic table for protons, neutrons, and electrons. For this video, you're going to want your periodic table out, so it's going to look like this. You got one of these in class. If you can't find yours, you could pull one up online, or there is one in your book. So we'll come back to the periodic table in a second. This is what a box looks like on the periodic table for each element. The numbers on there tell us things about protons, neutrons, and electrons. Quick review: a proton is a positively charged particle, an electron is a negatively charged particle, and neutrons are neutral. Protons and neutrons are found in the nucleus of an atom, and electrons are in the electron cloud surrounding the nucleus. So we'll use boron here as our example. So the capital letter, if it has might have two letters, so the second letter will be lowercase. That is the element symbol. Make sure you're filling in these notes as you go. Then the name would also be in every box. Now yours has a bunch of other numbers. We're going to focus on just two of them right now. The blue number in the upper left corner, we call that the atomic number. And the red number with decimals after it in the upper right corner, that's what we call the atomic weight or the atomic mass. Both names work for that number. So what do all these numbers mean? Well, the atomic number, so 5 for boron, tells us how many protons and also how many electrons. At least for now, in a later video, you'll learn when that's not the case with electrons. But for now, protons and electrons are both going to be determined by the atomic number. So boron has, for boron, protons are 5 and electrons there are 5. So 5 positives and 5 negatives would cancel each other out, so this would be a neutral atom. So the mass number is the number of protons plus the number of neutrons. So how do you determine your mass number? Mass number, if we don't know mass number and we don't know neutrons, they're both unknown, we would round our atomic mass or our atomic weight to the nearest whole number to determine the mass number. So let's say for boron we don't know how many neutrons it has. So 10.811 is our atomic weight or our atomic mass. Nearest whole number I'd round that to would be 11. So I would say boron's mass number would be 11. So how many neutrons does boron have? Well, mass number is protons plus neutrons. Or you could work backwards. If you know protons, in this case 5, and we know our mass number is 11, how many neutrons is that? So 5 plus what equals 11? Or you could work backwards and say number of neutrons equals mass number 11 minus protons, 5 in this case. So boron has 6 neutrons. So there's a couple ways to write element names or symbols with some of these numbers in them. One way is to write the name hyphen the mass number. So you could have something like nitrogen 15. We just have up there boron 11, the mass number. Another way to write it is what we call the nuclide symbol. And this has the mass number over the atomic number just to the left of the symbol. So when you write it, it's going to look like this. So this is nitrogen 15, like we have the name up above. So it's at 15 is our mass number, 7 as the atomic number for nitrogen. So if you go back to the periodic table, you can see nitrogen's atomic number is 7. So we could do borons as well, sorry. So we've got capital B, we've got 11 as our mass number, and 5 as our atomic number. All right, so let's do a couple examples. So calcium 41. So you find calcium on your periodic table. 41 is the mass number. So how many protons does calcium have? Well, we have to go back to our periodic table. Here's calcium. Okay, so atomic number is 20. So that means calcium has 20 protons and 20 electrons. How many neutrons does it have? So we take our mass number, 41, and we subtract our protons, minus 20, because protons and neutrons equal the mass number when you add them up. So 40 minus 20 would be 21 neutrons. All right, let's do sulfur now. So on our periodic table, we find sulfur. Sulfur is right here, so our atomic number is 16. So I go back, protons 16, electrons 16. Now neutrons, I don't know the mass number. When I don't know the mass number or the neutrons, I have to round my atomic mass to the nearest whole number. So here for sulfur, it's hard to read on here, but look on your periodic table. It should say 32.065. So I'm going to round that to 32. So this would be 32 minus 16, which would be 16 neutrons. Why don't you write down the practice problem in your packet and then enter that as the learning check when you're done.